In this video, we're going to look at indefinite integrals using u substitution. And these problems are going to differ than our normal u substitutions as they're going to require an extra substitution. So our first example is the integral of x squared times x minus 3 to the fourth dx. And usually when we have two polynomials, we would choose the one with the higher degree. But here, if you choose u to be x squared, then we end up with 2x as our du. And that's not going to be a substitution that will work for x minus 3. So in this problem, we're going to make u equal to x minus 3. Du is then equal to dx. And now, if we look at this, and we start looking at what we're going to substitute for, x minus 3 is going to be equal to u, and dx is going to be equal to du. But now we need to get a substitution for x squared. So we're going to do this by solving u is equal to x minus 3 for x. So here I'm going to have x is equal to u plus 3. And now if I square both sides, I have x squared is equal to u plus 3 squared. And here's our other substitution. So we can say that x squared is going to get replaced with u plus 3 squared. And now let's rewrite this in terms of u. So we have the integral of u plus 3 squared times u to the fourth and du. And now I'm going to multiply u plus 3 times u plus 3. So I have u squared plus 6u plus 9 times u to the fourth du. And now I'm going to distribute the u to the fourth. So I have the integral of u to the sixth plus 6u to the fifth plus 9u to the fourth du. And now we can use the power rule on each piece. So we're going to add 1 to the exponent and divide by the new exponent for each one. U to the 7th divided by 7 plus 6u to the 6th divided by 6 plus 9u to the 5th divided by 5 plus our constant of integration. Now for indefinite integrals, we need to replace our u with our x variable. So we have u is equal to x minus 3. So we have x minus 3 to the 7th divided by 7 plus, we have a 6 in the numerator and a 6 in the denominator, so those cancel. So we're just left with x minus 3 to the 6th plus 9 times x minus 3 to the 5th divided by 5 plus c. In this next example, I have the integral of x cubed times x squared plus 7 all raised to the 99 dx. And in this problem, just like the last one, if we chose u to be x cubed, we would be left with 3x squared, and that wouldn't help us substitute for x squared plus 7. So my u is going to be equal to x squared plus 7. Du is going to be equal to 2x dx. And now I want to rewrite this integral so that everyone can see the substitutions I'm going to make. So I'm going to rewrite x cubed as x times x squared times x squared plus 7 all raised to the 99 dx. And now the first substitution is the one we created, so x squared plus 7 is going to be equal to u. And then here we have x in the integral, and we have a 2x here. So I'm going to do 1/2 du is equal to x dx. So the next substitution that we have is x dx is equal to 1/2 du. So now the only thing we have remaining that we haven't substituted for is x squared. And I'm going to come to this u is equal to x squared plus 7, and I'm going to solve for x squared. So I'm going to say x squared is equal to u minus 7. And now we have x squared equal to u minus 7. So now we can rewrite this in terms of u. And we have our x dx is equal to 1/2 du. I'm going to put my constant out front. X squared is equal to u minus 7. And x squared plus 7 is equal to u. So we have u to the 99. And now du. And now I'm going to distribute the u to the 99 through the parentheses. So I have u to the 99 times u is u to the 100 minus 7u to the 99 du. And now I'm going to integrate using the power rule. So I have 1/2 times u to the 101 divided by 101 minus 7 u to the 100 divided by 100 plus c. Now this 1/2 is distributed to both of these terms. So I'm going to rewrite this. While I'm replacing my u with x squared plus 7, I'm also going to multiply the 2 times each of the denominators. So here I'm going to have x squared plus 7 to the 101 divided by 202 minus 7 times x squared plus 7 to the 100 divided by 200 plus c. And that's how we'll complete u substitutions that don't follow our standard rules of u substitution.